Thank you for joining this lesson. We're going to look at the derivation of the three equations of linear motion, and we are going to consider a body accelerating uniformly. A body accelerating uniformly. So in this case, we are going to give it the acceleration small letter a. We know very well by definition that acceleration equals to change in velocity per unit time, or the rate of change in velocity. Therefore, for us to get the acceleration, we usually take final velocity v minus the initial velocity u, and we divide by 2 the change in velocity rate. Therefore, when we cross multiply, this is going to give us at equals to v minus u, because t multiplies through there, such that for us to remain with v on one side, then we can say that v equals to u. When u is taken to the other side, it becomes positive. Then we have at there. Therefore, the first equation of linear motion is v equals to u plus at. This one is called the first equation of linear motion. Then after that, we get to the derivation of the second equation of linear motion, and we consider displacement s. Therefore, displacement s is usually given by average velocity times time. Average velocity times time. So we don't consider a certain velocity, we just take the average of velocity, because the body is not having a constant velocity, it is accelerating. Therefore, the velocity we consider is the average. Average is given by, when we say displacement equals to, average velocity is when we take the final and the initial and we divide them by 2, then this we multiply by the time taken, such that now we can say, according to equation 1, from equation 1, we know that v equals to u plus at, such that instead of v, we can have u plus at, and we will say from this one, s equals to, we have instead of v, u plus at, that is from equation 1, then plus again we have a u, everything divided by 2, then we have times time taken. Therefore, we have replaced v with u plus at according to equation 1. So this means we can have our s equal to, we have u and u again, so 2u plus at divided by 2, then we multiply everything with the time taken, such that now we can make another step here where we will say s equals to, when we divide every element here with 2, we're going to get the 2 cancelling here, such that we have u plus this one, the 2, because it cannot simplify, it remains, such that we have half at, then there is multiplying with time now in the outside, such that now we will have s equals to, when we open with t, we will get ut plus half a, and t becomes squared because there is already a t, and now we are multiplying with t again. That gives us the second equation of linear motion. So we're going to conclude that s equals to ut plus half at squared. This one is called the second equation of linear motion. we're going to get to the third equation of linear motion, and we again consider the definition of displacement. Remember to subscribe to this channel as we continue reading, and share the link with your friends. So we have S is given by the average of velocities, so divided by 2, and we multiply by time t. That's how we get displacement. But we know from the first definition, from the first here, we can make t the subject of this expression, such that we can say t equals to v minus u out of acceleration. So that is, when we cross multiply here, we have at equals to v minus u. Then to remain with t, we divide by a, so that t becomes v minus u out of a. So we can now fix it here such that s is given by u plus v out of 2. Then instead of t now, we have v minus u out of a. After this step, we can say that s equals to, we have in the denominators 2 times a. Therefore 2 times a can be multiplied in both cases. We multiply by 2a and 2a on the other side to do away with the fractions, such that we have 2a times s. So I think this one is not necessary. 2a times s. Then on this side we've just remained with u plus v and v minus u. When you try to examine this part well, you realize that this part is the roots of a difference of 2 squares, because when we have a squared minus b squared, according to mathematics quadratic expressions and equations, the factorized form of this, because we call it a difference of 2 squares, is a plus b and a minus b. So since we have v plus u and v minus u, then the expanded form is going to be v squared minus u squared. Therefore we can say, or else you can just expand using the long method, such that 2as is given by v squared minus u squared. That is when you expand the right hand side. And after that, we're going to arrive at v squared equals to, u squared on the other side becomes positive. Then we have 2a times s. So this one is the third equation of linear motion. Therefore the third equation of linear motion, v squared equals to u squared plus 2as. This one is the third equation of linear motion. What I was saying about this part is that you can open the long method by saying 2a into b. It is v plus u and v minus u. So opening in the long method, we can have v multiplied by everything in the second bracket, v and v minus u, then u and again v minus u. So that opening this becomes v squared minus uv plus uv, when you open here, minus u squared. So that uv cancels out, and we'll have v squared minus u squared. So this one has already been applied here. So that is how we derive the 3 equations of linear motion. Thank you for following. Subscribe to this channel and share the link with your friends.